Good day everyone. In our previous lecture, we discussed about the various factors that help us identifying the payload for our drone. However, to further ease our selections, we will be discussing about the commonly used payloads in our current lecture. This again will help us a lot when we are deciding on the payload when we use it for a particular application. Let us look at it in detail in our upcoming slides. We have seen these drone-led landscape shootings in multiple corporate or personal videos. It is a coveted high-end photography. However, the actual applications of high-definition drone cameras are far deeper and with much larger impacts. Drones have a complete 360-degree panning gimbal for the HD camera. The drones, with their endurance and stability, offer shake-free imaging in each scenario. They give us live surveillance and reconnaissance for multiple industries and security forces. The drone flight can be automated, and all the operator must do is control the camera. They can dynamically change the drone's path for closer observation of anomalies or targeted points. HD drone cameras lay the foundation for a critical analytical development: photogrammetry and orthomosaic imaging. Photogrammetry technology enables operators to take realistic and accurate readings with photographs. Essentially, operators can detect the exact height, breadth, or depth, all dimensions in volume detection. Orthomosaic imaging is when multiple HD aerial photos are merged together using photogrammetry to create a perfect geo-corrected layout of an area. This is essential for overview while they're conducting site or field evaluation. From this, you can get an idea where all imaging cameras can actually be used. So definitely think about it, what we have discussed over here about imaging cameras, because most of the times I've observed drones use imaging cameras in a lot of different ways. You might have heard a lot about thermal imaging, and it's the easiest to grasp. Thermal cameras capture distinct infrared radiation to visualize even the most obscure marks across long distances. Thermal imaging is broadly classified into black hot and white hot depending on the spectrum, each having their own specifications. Thermal imaging is usually associated with night vision as they function beyond the human visual range. Drone-led thermal imaging gives a huge boost to homeland and critical defense forces. They help with detailed surveillance and reconnaissance. They act as scouts to gauge first-hand intelligence to plan future activities. For enterprises, drone-enabled thermal imaging is extremely important. They can spot faults and anomalies across vast agricultural fields, solar installations, coal stockpiles, critical equipment, etc. They help cut down on the manual surveillance required to spot these hidden faults, which are often fraught with dangerous human interventions. Drones can track the fault location, directing the correctional forces to do their thing. This saves resources, time, money, and human lives. Hyper and multispectral imaging processes electromagnetic information for each captured pixel. The difference between hyper and multispectral lies in the range of spectrum they process. Drone-enabled spectral imaging is used to detect problems that wouldn't be otherwise visibly detectable. They have a huge application in the agricultural sector. They can detect the health of a standing crop, even diagnose them with diseases even before they show visible signs. They can showcase the ripeness of each batch of crops, helping the farmers to optimize their harvest. It also helps them plan their entire operations right from the resources, warehouse, transport, etc., required for distribution. They are also useful in detection of harmful fumes, emissions in industrial zones, or oil seepage near a plant. It's not just drone-enabled HD cameras that have such an impact on operation management. There are many other imaging technologies that greatly enhance processing capabilities of drones. One major technology here is LiDAR. It's an acronym for light detection and ranging. LiDAR uses laser pulses to accurately create a virtual picture of any entity or terrain in its path. It works in a similar manner to radar and sonar. It processes the time taken between emission and the reception of a laser pulse to draw up a recreation of the target. Drone enabled radar technology helps create accurate 3D models of equipment of the land. They help create clear vegetation and watershed mapping for a location. Furthermore, they help with equipment and project maintenance. Drone-led lidar can be used to detect surface anomalies across a bridge, a building, or a boiler. They will point out and tag even fine faults like cracks, which can be fixed instantly without any disastrous implications. Crops require consistent fertilization and spraying in order to maintain high yields. Traditionally, this was done manually with vehicles or even via aeroplane. These methods are not only inefficient and burdensome, but they can be very costly as well. Drones can be equipped with large reservoirs, which can be filled with fertilizers, herbicides, or pesticides. Using drones for crop spraying is much safer and cost effective. Drones can even be operated and completely autonomously programmed to run on specific schedules and routes. For example, if there's a fungus breakout in a certain section of the crops, drones can be used to spot and treat the issue. With the speed at which drones can operate, you can diagnose and treat potential crop issues before they become a widespread issue across the entire farm. Spot spraying of crops used to be incredibly difficult. You had an issue with weeds or a certain crop, the entire acreage would have to be sprayed. This is a huge waste of time and resources, as someone will have to walk the entire acreage, plus there are overall costs of pesticides and the associated environmental cost of chemical usage. With spot spraying afforded by drones, this same task can be accomplished in less time with fewer monetary resources and a reduced environmental cost. Using smaller, much safer drones along with RFID scanners can be used to find stuff in giant buildings, especially warehouses. When RFID tags started replacing barcodes in warehouses, they were supposed to help automate and improve the accuracy of inventory management. The small tags, which are briefly activated by the radio frequency of a reader, have been adopted and used everywhere. The drones, which are equipped with RFID readers, can take the place of inventory taking humans and complete the job with less hassle and time. High boxes that a person would need a ladder or lift to access can be easily reached by a drone. Drones can be programmed to independently navigate spaces, and they are better at executing large scale repetitive tasks like taking inventory than humans. Commercial drones have garnered mass interest with the vision of fast drone enabled package deliveries. Package drops were in play for some time now. Drones were used to drop medical supplies in disaster struck areas as one of the activities they performed in rescue operations. In the past few years, precise package deliveries using drones has captured the collective imagination of the people and companies alike. With large companies such as Amazon, Walmart, UPS, Google, and other global postal companies investing in drone delivery projects, it is only a matter of time before their drone parcel delivery service becomes a reality. The driving power behind delivery drones innovation is to cut down on delivery time of packages which are to be delivered. Many companies are promising to deliver packages in 30 minutes or less, but how and where the drones take off is crucially important. Few ways of drone delivery have been adopted. The first course is to deploy the drone from dispatch centers located around the city. The traveling speeds and built-in battery time could reduce the range of a drone to around 20 to 30 kilometers. This means multiple dispatch stations would be needed for a city-wide fleet. The second method of delivery would be using the traditional delivery trucks that will operate as a dispatch center for all the drone delivery operations. Drones will work with the road-bound vehicles navigation system to deliver parcels to more rural areas. To summarize, We looked at some of the most frequently used payloads, such as imaging cameras, thermal cameras, hyperspectral imaging, radar, agricultural payloads, RFID scanners, and package delivery. Once we have decided on to the payload, how do we integrate the payload in the existing drone? In our next lecture, we will precisely focus on this topic. Thank you very much.